Okay guys, so as we start the statistics unit, which is unit 9, we're going to review some of the simple population calculations that we often do, measures of central tendency that you're familiar with from Algebra 1. And the first of those measures of central tendency, which you should be very familiar with, is the mean. So the mean of a set of data is just calculated by adding up all of the values here and dividing by however many values there are. And this should be review, so why don't you pause the video and calculate that mean of the set of data that you've got in front of you. So hopefully you did that correctly and you just added each of these. Remember, if there are duplicates, you do still need to add them. So I added 272s, I added 284s, 288s, and so on. And there are 18 numbers here, so just as I would do if I were trying to find the mean of all of your test scores, in this situation they're all added up, and that gives us 83.72. So there's a symbol that I want you to see that we're going to be using to represent the mean throughout this unit, and that is called a mu. And it looks like a U but with a big tail on the front of it. So a mu represents our mean average whenever we're talking about measures of central tendency within our statistics unit. And it's going to come up a lot, and so you're going to want to recognize that symbol as the mean average of a set of data. Okay, so what percent of the scores, if we go down to B, lie above and below that mean? And so luckily they're all separated, or they're ordered chronologically and from least to greatest. So we could say that numbers that are above that average, maybe I'll highlight those in yellow, 83.72, well 84 would be greater than that, and all of these numbers would be greater than the mean, but we also would have all of these numbers that are less than the mean. So the question doesn't say how many, it says what percent. And I see here 7 numbers, and here I see 11 numbers. So to calculate that, I'm just going to turn those into percentages. So my above number would be 11 out of the 18 numbers that I have, which is approximately 61.11% of my numbers. And my below would be the rest, so 7/18, which is approximately 38.89%. So that's one way that I could look at this data, and I might have assumed that because this is a mean, half my numbers would be above and half would be below. But that's not always the case, because what we're going to see is that in some sets of data, we have numbers that really weigh down the average a lot on one end or another. And in this case, we end up with a few numbers that are really, really high, that are dragging us in the above the mean average direction, and numbers that are not as below the mean as some of the numbers that are above the mean. So the next component of these measures of central tendency, that's the really important new piece of information in this unit, is the standard deviation. And before we actually calculate that standard deviation, I'm just going to show you the symbol that we're going to use to represent it and the formula that is used to actually calculate it. So we did use this symbol, which is a lowercase Greek letter sigma, in the last lesson, but that's going to represent our standard deviation. And just to walk you through the formula that's used, remember when we're using standard deviation, we're describing how close our data is to the average. So we're saying that if it's within one standard deviation of the average, then it's close to the data. If it's outside of one standard deviation from the average, then it's far away from the data. But how is that standard deviation number calculated? So this is where that number comes from. Basically, if I take any piece of data, which is what that xi represents, one of the pieces of data, and I find the difference between that piece of data and the mean, that's going to tell me how close that piece of data is from the average. But I'm going to have a lot of those. So what I'm going to do is I'm going to take each piece of data, each one of these, subtract it from the mean, and square it. So for example, I would take this number 80. 80 minus 83.72, and then I would square that number. And I would do the same thing with 84 and 78 and 100 two different times, and 99 and all of these numbers, and I would add all of those together. So we'll use a uppercase sigma, if you will. All right, and then I'm going to take the average of that. So I've taken the difference between each number and the mean, squared them, added them all together, and I'm going to divide that number by however many pieces of data there are. And finally, take the square root of that whole thing, and that's going to give me my standard deviation. Now, fortunately, you don't have to memorize that formula because there's a really nice way to do this using Desmos, which is what you're going to use. So what you'll do from now on if you want to calculate the standard deviation is you'll just open up Desmos, and then you're going to click this plus sign here, which is going to open up the menu to determine what you're going to type into Desmos, and we're going to select table. And so what we're going to do in this list, in the X1 column, is we're going to put every single number that we have. So 56 is the first number, and then our second number is 68, and then we have 72, and we have another 72, and we'll continue. 75, 78, and this is going to lengthen the video, but I can't pause this, so I apologize. 80, 84, twice, then an 85, and I'm realizing here that I did not type 75. That would mess up all our numbers. Okay, so 88, so make sure you are double checking these as you're typing them in. 2 88s, a 90, a 93, 95, 99, and then 2 100s. And I'm just going to double check that I have the right number of them here. All right, so this is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Well, the scrolling didn't work. So anyway, I'm pretty sure that I have the right numbers here. If I don't, I'm going to have to redo the video. But what I can do to find some of these values is rather than typing them all out in a calculator one by one, adding them all together, Desmos has a pretty nice feature where I could actually just type the word mean, and then in parentheses, I can just specify that I want the mean of the values that are in my X1 column, right? And so I get 83.72. So I'm pretty confident that I've done this correctly because that's the same number that I just got. If I want to find standard deviation, I do the same thing. I'm just going to do STDEV, and that's telling Desmos that I want the standard deviation of the numbers that are in the X1 column. And so it gives me 12.05 or 12.048, depending on how specific we want to be. So this is how you're going to calculate this in the future if you need to. All right. So the standard deviation of our data, we will say, from the calculator, is 12.05. And that is how we determine whether or not each value is close to the mean, if it's a number that's close. And that's what we've been doing all along here, is trying to define closeness. So now we've decided that if one of these people took the test and they are within that of the average, then they are close to the average score. If they're not, then they're far away from it. So if they did better than 12.05 greater than that number, then they were way better than the most of the class. If they did worse than that, then they were way worse than most of the class as far as their test score. If they were 5 away from this number, or 6 away from this number, or even 10 or 11 away from this number, they're within this, so we would say they are close to the average. And right now we're just informally describing these things as close or far from the mean average. And so we're going to take a look at another set of data here. This is track times of runners, and this time we're going to sort of take this to the next level. So I'd like you to answer D on your own. How many runners are within one standard deviation of the mean? And in order to do this, you're going to need to calculate the mean of that data, and you're going to need to calculate the standard deviation of that data, but you should do it all using Desmos. So now I'm going to reveal those actual numbers, and I got a mean of approximately 118.27, a standard deviation of approximately 37.05. And if you rounded to the thousandths place instead of the hundredths place, that's great. That's even more accurate than what I'm doing here. To figure out how many runners are within one standard deviation of the mean, I think it's useful to create a number line and put the mean right in the middle of that number line. So my mean is 118.27. And I want to know how many runners are within one standard deviation. So I'm going to put another mark to the outside in either direction of that. And that's going to be +1 standard deviation and -1 standard deviation in either direction. So if I add this number to the mean, I will get 155.32. And that's that value. If I subtract the standard deviation from the mean, then I get 81.22, and that's that number. And so the question that's asked is how many runners are within that range. So what I'm going to just visualize here is a marble for each person who belongs in that range. And so 83 would belong there, right? This person would go in this range, so they'd be in that part of our number line. And so with this, and so with the 88, they'd be in there. The 103 would be in this same range, so I'll drop him there. 109, still less than 118. 110, still less than 118. But 120 is greater than 118, so it's still in this range. 122, 122, 134, 138, 149. And so all of those would also go in this area. But I would have to leave out these and that number because they are not within one standard deviation in either direction. So if I count all those up, that's 12 runners. So I would say 12 of these times are close to the mean. Now outside of that, I've got some other ones, right? I could go one more standard deviation beyond that and add another standard deviation here. And so that would get me 192.37, and I could subtract another standard deviation there, and that would put me at 44.17. And so now I could place these other numbers. I'll use green. So this 41 is actually less than 44.17, so that 41 would be way out there, less than 2 standard deviations away from the mean. 170 would be here in that range, and 200 is above 2 standard deviations above the mean. So how many runners are outside of 2 standard deviations from the mean? Well, there are just 2 runners. It's just this guy and this guy, because this number represents the mean minus 2 standard deviations, and this number here represents the mean plus 2 standard deviations, and both of these are outside of those ranges. So since they're both outside of 2 standard deviations from the mean, we would say that they are really not close to that mean. And our following lessons are going to deal with this idea of closeness. I know this is a long video, but we're going to do some stuff with standard deviation coming up in the next few lessons.